Okay. All right, so for these questions here, okay, I did post the formulas for you guys as well, okay? And now I figured it'd be good to go through these together. Okay, so for the first one, you can see, okay, for the first one, hopefully you can see that A is 1, B is 8, and C is 4. So we have A is 1, B is 8, C is 4. Okay, so we want to calculate negative B over 2 times A, right? Okay, so that's negative 8 over 2 times 1. That number's not bad. That's just negative 4, right? And now we have negative 4 squared, right? We have to get the y value, so we have negative 4 squared plus 8 times negative 4 plus 4. And of course, that's equal to 16 minus 32 plus 4, which is minus 12. So the vertex is minus 4 minus 12. The axis of symmetry is minus 4. And so again, we can get the range, right? Because we know A is positive, so we know the graph opens upward, as you can see. And since the vertex is down here, right, the range has to go from minus 12 to infinity. So again, even without graphing it, we can get the range. Okay, and the domain, of course, is always all real numbers. For the x-intercepts, here I actually did the calculation for the y-intercept. You know, if you just replace x by 0 and you get 4. I mean, you are definitely allowed to use calculators on the exam. I expect that, especially with something like this. I definitely cannot do these calculations in my head. For the x-intercepts, remember, I would just use the quadratic formula. So in this case, you would have this. You know, you have your A, B, and C. And your negative B would be negative 8 plus or minus the square root of B squared, which is 8 squared minus 4 times A times C. A is 1, C is 4, so we have this. So in this case, we have over 2, you know, A is 1. So we have this. And if you subtract here, you get the square root of 48. Now, 48, unfortunately, is not a perfect square. I will tell you ahead of time how many decimal places to round to. Okay. As you can see, we do get two solutions here. We have negative 8 plus this over 2. We have negative 8 minus this over 2, right? So we get a solution from addition, a solution from subtraction. We have these two, as you can see. And now we have enough to get our graph. I mean, if we were to sketch it. So you can see that, again, yeah, the vertex is here. The axis of symmetry I did actually sketch. Let me highlight this stuff. So here again is the vertex. Here's our x-intercept and another one over here. Y-intercept again, that's over here where it crosses the y-axis. So we have everything we have. We have everything here. I know it's kind of silly because, you know, we're not sketching it by hand, but I still think you should be able to calculate, you know, the vertex and stuff, the axis of symmetry. I still think it's good to get those by hand. You can't rely 100% on a calculator or even a graphing one. All right, so we have that example. Let's do another one. Let's do the second one, I mean. So here we have A is -1, B is 7, C is 15. So, same thing as before. We have to get minus B over 2A. And that turns out to be minus 7 over 2 times -1. So we get 7 over 2. You could leave it as 7 over 2. I just thought it'd be easier for everyone if I wrote it as a decimal, especially since it's an easy decimal. And so then to get the y value, we have to substitute, right? The y coordinate, of the vertex is the function value at the x coordinate. So we have this. And as before, doing this, right? We end up with this stuff. This I probably would use a calculator, although it's not terribly hard to do by hand. But I'll be honest, I used the calculator. So now we know what the vertex is, right? We know the axis of symmetry as well. So that's what we have here. Okay. Oh, no, that's right. Notice here that A is actually negative, right? So A being negative, that tells you the graph has to open downward, like this. Vertex is on top. Wait, what am I doing? Getting ahead of myself. There we go. So we have to open downward. That's why the range is from -infinity to 20.25. That's what our range is. That's good. I was going to say, for the x-intercepts, hopefully you can see that are going to be x-intercepts. I mean, you could really just dive right in and get the quadratic formula. You could. But because it's pointing downward, and because the vertex has a positive y coordinate, right? So the vertex is, where is that? Up here somewhere? You can see that because it opens downward, right? It's going to have to pass through the x-axis. So there are going to be x-intercepts. I mean, what are they? I don't know. But we know it has to somehow pass through. I mean, I hope that makes sense what I'm saying. All right. But now we can actually get the x-intercepts. And the y-intercept, as you can see. The y-intercept you can see is 15. We have, again, using our quadratic formula, we have all this. So we have, again, we just substitute, right? And again, we have our confirmation of that we are right that there are x-intercepts. Right? How do we know that? Because when you plug it in, mostly because you can see that the square root here is going to be positive. I mean, 109 is not a perfect square, but that's okay. So anyway, we have minus b, minus 7. B is 7, so 7 squared minus 4 times -1 times 15 over 2 times -1. So we end up with this. And again, here's where you could probably use a calculator. And why is that? I don't know why that negative is there. But we end up with this stuff. Okay, that's good. But anyway, we now have our graph and we have everything. So as you can see, the vertex is up here. We have our y-intercept, as you can see. We have our x-intercepts. And you can see that, the graph looks like this. Opening downward, which is, again, confirmed because A is negative. Okay, good. Okay, are there any questions so far? For the third one, same idea, right? we have A is 1, B is 5, and C is 9. So as usual, we get the vertex. We do this calculation. I know there are some things in math that you just have to do like a procedure, and really this is one of those. So you do this first, then you do that, then you do this, then you do that. You know, that's going to happen in math. Not always, but it does. So in this case, we have minus 5 over 2 times A, where A is 1, so we have this. So we get minus 5 halves. That's not too terrible either. That's just negative 2.5. Plug in the y value. Excuse me, to get the y value, you plug in the x value into the quadratic function. We get this. As you can see. From here, we get our vertex. X coordinate, y coordinate, axis of symmetry. And again, A is positive. So the range here is this. Okay, now, just out of curiosity, I wonder, could there be x-intercepts? I mean, yeah, we have the quadratic formula. Let's just see something. Okay, so the vertex is, let's see, it's somewhere here, right? The x-coordinate is negative. The y-coordinate is positive. So I don't know where it is exactly, but let's just say it's over here. Now, we know that A is positive, right? So this graph is going to go up. I mean, I don't know exactly where it's going to go. I mean, the y-intercept, it's got to cross the y-axis eventually. So let me just try and fix that a bit. Oh boy, I think I made it worse. See if I can clean that up just a little bit. I don't want to waste too much time graphing these. There we go. So it's going to do something like that. But let me ask you this, though. Will this have any x-intercepts? I mean, it's going to be, no, it doesn't, right? Because it's going upward away from the x-axis. There's no way this can cross the x-axis, which is always horizontal. So because of that, we should be able to see right away, oh, well, there's not going to be any x-intercepts. Let's just confirm that. So the y-intercept, of course, that should be easy to see. I mean, even on the previous slide, I hope you were able to see it. It's always the constant term, and this just confirms it. But you can see from here that if we calculate, if we use the quadratic formula, we get the square root of negative 11. That's not a real number. It's what we call a complex number. Actually, no, check that. It's an imaginary number, which is a complex number, I guess. But basically, this is not real, is what I'm saying, the square root of a negative. So this can't have any x-intercepts. And so because of that, and we can see, yeah, this never crosses the x-axis. Not done yet, just want to get the recording.